A context-free grammar is given S to ASA and S to AA. Now we will have to construct a parse tree for AA using backtracking parser, and then we'll have to tell that how many backtracking will be done to get that particular string AA exactly. So first of all, we will see, or that particular parser will see, starting from the start symbol capital S. It can have the first symbol small a matching to the final string AA in the production ASA. So it will apply initially from S to ASA. After that, the next symbol again is small a. So from this particular S again, the same production ASA will be applied. But after that, when we will see, again the next production can be S2 ASA, just because we'll have to resolve this particular S also. So to resolve this particular S, we'll have to resolve it by the first production from S, that is ASA. Now it will not match to our final string, just because our final string is having only double A. That means backtrack will be done. That means whatever the production rule we have applied, that particular production rule should be switched. That means from this last S we'll have to have one backtrack. So number of backtracks I am writing in the right hand side, one backtrack we will have to do, and from this particular capital S, whatever the last production we will have to apply or we had applied, we will have to switch it to some other option. So from this particular S to ASA, now we'll have to see the other option, that is S to AA from this particular last capital S. So the next parse tree will become something like S to A and again S to A. But this particular production rule will also have a problem, just because this will lead me to have 4 or 5 more than 2 A's in my final string. Again I'll have to backtrack from here to this particular point, that means backtrack number 2, and then again I'll have to backtrack to some other point, just because there is no any other option I can have from this particular capital S. That means one more backtrack from here to here. So from this particular capital S, now we will have to apply the other option, that is S to AA, so that we can check that particular option also. So till now we had 3 backtracks, and after 3 backtracks my tree will be something like this, and now I'll have to apply from this particular capital S to AA. Now again this solution is also having a problem, and that particular problem is I'm having 4 A's here and I need only 2 A in my final string. That means again I'll have to have backtrack. So one more backtrack will be done from here to here, that is backtrack number 4, and there is no any other option from this particular capital S to apply apart from these two whatever we have previously done. That means one more backtrack will be done from this particular end to this particular capital S. That means again I will have only one capital S at the top, and the other option from that particular capital S will have to choose. So till now backtrack number 5 we have done. So after these two backtracks I'll be having only capital S in my parse tree like this, and from this particular capital S now I'll have to apply this AA. Now I have got my final result, that is S2AA, and in my terminal strings I am having 2 A's. So number of backtracks for this is equal to 5.